Hi everybody, today we're looking at the process of something called polynomial division, and it actually uses the process of long division that you would have learnt probably back in grade 4 or something like that. So we're going to first of all remind ourselves about how long division works and then look at how we can adapt the process for long division. So if I'm trying to do 2,897 divided by 26, and the process of long division says that I've got to start by dividing the first section of the dividend. So the dividend is this number here, and this is the divisor, and the quotient will be what we get up the top. So they're the key terms that we're going to be referring to. So you've got to divide the first section of the dividend by 26. Now 2's into 26 don't go because 2 is below 26, so then I consider both the 2 and the 8. And so I'm going to divide 28 by 26. So 28 by 26 goes one time. And then what I do is I take this 1, so I take the first part of the quotient and I multiply it by 26. So 1 times 26 gives me 26, and then I subtract it from the 28. So 28 take 26 gives me 2. And then I bring down the next part of my dividend, which is the 9, and I think about 26 or 29 divided by 26. Now that also goes once, so I put a 1 up there as well. And I then take that 1 and I multiply it by 26, and I subtract it this time from the 29. And if I do that, I get 3. And so then I bring down the last part of my dividend, which is the 7, and I think about 37 divided by 26, and that's also 1. And then I take the 1 and I multiply it by 26, so 1 times 26 just gives me 26, and I subtract those, and that gives me 11. And now I'm at the end of my dividend, and so this is my answer. So 2,897 on 26 is 111, and then if I was to write this as a mixed number, we've got a remainder of 11 over 26. So really all I've done is I've converted that from an improper fraction to a mixed number. Now it may not have been made explicit when we were doing mixed numbers back in, I think probably the last time you would have looked at them was year 8, but a mixed number is actually an addition. It's 111 plus 11 on 26. That's the mixed number we've got there. Okay, alright, so how are we going to be using this process to divide polynomials? So here we've got a quartic, so something to the power of 4. So 3x to the power of 4 plus 4x cubed plus 2x squared plus 3x take 1, and we're dividing it by the quadratic x squared plus x take 2. Now I'm just going to size down my screen a little bit so we can read the instructions on the left. First of all, to divide the first section of the dividend by the first section of the divisor. So my dividend is this massive long quartic, and the first section is just this, 3x to the power of 4, and we're just going to be dividing that by the x squared. So instead of section, we could really say first term of dividend by first section of divisor, and the result is going to be the first term of the quotient. So 3x to the power of 4 on x squared, well, there's a common factor of x squared that we can cancel to leave us with 3x squared. So that's my first part of my quotient, and I'll line it up so it's above the x squared in my actual quotient. So let's just make a point that we line up with term, and it's specifically the x squared term in dividend. That just helps us keep consistent. So that's 3x squared. Okay, now it says multiply the first part of the quotient by the divisor and subtract from the first part of the dividend. Okay, so like we do in long division, we take the 3x squared and we multiply it by this entire divisor. So it's 3x squared plus x take 2 gives us 3x to the power of 4 plus 3x to the power of 3 take 6x squared. Okay, so I'm going to subtract it from this first part of the dividend, and it's all first three terms. So 3x to the power of 4 plus 3x to the power of 3 take 6x squared. And when I subtract that, the first thing I get is 0. But if you think about it, I've set it up so I get 0. You see, I've set it up so I've done 3x to the power of 4 divided by x squared. So when I just multiply by x squared, I have to get 3x to the power of 4 back. So this must be 0. If it's not 0, you've done something wrong and you need to check your working. Now it's 4x to the power of 3 take 3x to the power of 3. So it's just going to leave me with x to the power of 3. And it's 2x squared take negative 6x squared, which is 2x squared plus 6x squared. So it's plus 8x squared. Okay. Now it says bring down the next term of the dividend. I've said see the division because I'm showing that. So bring down that 3x. So the number of terms must match the number of terms in the divisor. So I've got to have 3 terms. And then I repeat the process. So I'm then going to take this x cubed and I'm going to divide that by x squared. X cubed divided by x squared, well that gives me x, and I line that up with the 3x in the dividend. Then I take that x and I multiply it by all the terms in the divisor. So x times x squared plus x take 2 is x cubed plus x squared take 2x. Okay, so I'm going to subtract that. So x cubed plus x squared take 2x. Do the subtraction and I notice first of all that I get an x cubed taking an x cubed, so that's 0. So it fits with the idea that that must be 0. Now 8x squared take x squared is 7x squared. 3x take minus 2x is 3x plus 2x, so that's plus 5x. I bring down the negative 1. I take this x squared and I divide it by the x squared in the divisor. That gives me 7. So I put a 7 up above the take 1. And then I multiply that 7 by everything in the divisor. So 7x squared plus x take 2 is going to give me 7x squared plus 7x take 14. And I'm going to subtract that. So 7x squared plus 7x take 14. So 7x squared take 7x gives me 0. That again fits. 5x take 7x is going to give me take 2x. And minus 1 take minus 14 is minus 1 plus 14. So plus 13. And so now we've got minus 2x plus 3. And here the degree of this is 1. Now the degree is the highest power of x, and the degree of the divisor is 2. So minus 2x plus 3 forms, or plus 13, forms the remainder. So when we had 11, we said, well, that's less than 26. Here, the degree of our polynomial, or degree of our terms, is less than the degree of the divisor, so that means it's, in this case, it's the remainder for this idea. So we've done a division, and what have we got? Well, we had 3x to the power of 4, and I'm just going to move my screen up a bit, plus 4x to the power of 3 plus 2x squared plus 3x take 1. We divided that by the quadratic of x squared plus x take 2, and we saw that it equaled 3x squared plus x plus 7 with a remainder of minus 2x plus 13. And if I was to write that in the form of the mixed number, I've got to put my remainder over my divisor, which is x squared plus x take 2. And there's a plus in the middle. That's using mixed number form. Okay, alright. Now, that can get quite tricky, and it's really important that you understand and can follow that process. But there's another way to do it which is easier. However, the easier way isn't necessarily a true mathematical way. It's a trick. And so there are a couple of key things, I call them caveats, or basically conditions under which you can use it. You can't just use it in any case. Now the first case is that it only works when you're dividing a polynomial, and that can be a polynomial of any degree. The highest power can be anything. But what you're dividing it by, the divisor has to be linear. So let's have a look at how it works. So I'm taking that same quartic, power of 4, 3x to the power of 4 plus 4x to the power of 3 plus 2x squared plus 3x take 1, and I'm dividing it by x plus 2. So I'm not dividing it by a quadratic anymore. It wouldn't work for this case that I had above. So I'm now dividing it by a linear polynomial. So the first thing we have to do is we have to find the root of the linear polynomial. So the root is just what value of x makes this equal 0. So if x plus 2 equals 0, then x equals minus 2. Now, I then set up my division with the coefficients only. So yes, I have my root out the front, but instead of having 3x to the power of 4 plus so on, notice that these are coefficients only. Now, the process then follows. First of all, I bring down the leading coefficient. That gives me my 3 out the front. I then multiply it by my root, so I multiply it by minus 2, which gives me minus 6, and then I add that to the second coefficient. So 4 plus minus 6 is 4 take 6, which is minus 2. Now I might do this above the arrow, so that's a minus 2 there. And then I keep going. I take my minus 2 and I multiply it by the root, which is also minus 2, and I get positive 4. And I add that to the 2, so I get 6. And then I multiply it by minus 2 again. And what do I get? I get minus 12, and I add that to 3. And so I get minus 9. And then I multiply that by minus 2, and I get positive 18, add that to the minus 1, and I get positive 17. Now, this 17 is the remainder. And so then, after the remainder, we've got the constant term, we've got the x term, we've got the x squared term, and we have the x cubed term. Now that fits that we only go up to x cubed because we're dividing a quartic by a linear. So it's kind of like, so the power, the highest power comes down by 1. Okay, alright, so what did we get? Well, we were doing 3x to the power of 4 plus 4x to the power of 3 plus 2x squared plus 3x take 1 all over x plus 2, and so then we got 3x to the power of 3 take 2x squared plus 6x take 9, and then the remainder over x plus 2 using mixed number form. Now I'm sure you can see that that's a lot easier, but there's also another condition under which this gets used. So if you're doing the division x squared plus x take 2, all divided by 2x take 3, well, let's just go through with it. 2x take 1 equals 0. It's x equals a half. I think I said we're dividing by 2x take 3, but we're dividing by 2x take 1. And so then if I was to do this synthetically, I'd bring down the 1, multiply the 1 by 1/2, add that to the 1, so I'd get 1 1/2, which is 3 on 2, and then multiply that by multiply that by 1/2, so I get 3 on 4, add that to the minus 2, and I think I get minus 5 on 4. So, when we do that, notice that we're dividing by 2x take 1, but that assumes, when we tell the process that we're dividing by 1/2, it actually assumes that we're dividing not by 2x take 1, but rather that we're dividing by x take 1/2. In other words, this process only works if the coefficient of the x term is 1, and that's for the divisor. So it only works if the coefficient of the divisor is 1. The coefficient of x in the divisor is 1. So when we come out with our result, we're actually doing x squared plus x take 2 is equal to x minus 1/2. And so that is equal to x plus 3 on 2 plus minus 5 on 4 all over x take 1/2. So we didn't want that though. We wanted x squared plus x take 2 divided by 2x take 1. And so we have to multiply everything by 1/2. Because when I multiply x take 2 to x take 1/2 by 2, I will get 2x take 1. And so because we multiply every term by 1/2, we're not actually changing our equation. Down here I get 2 times x take 1/2, and I also get 2 times x take 1/2 over underneath the remainder. Now the actual quotient becomes 1/2x plus 3 on 4. And so then my final answer of x squared plus x take 2 on 2x take 1 is x on 2 plus 3 on 4 plus minus 5 on 4 all over 2x take 1. And so we have to remember that those two caveats for synthetic division. It only works if you are dividing by a linear polynomial, and it only works if the coefficient of the x term is 1. And so that might require some manipulation of the final answer when we do that.